Hello everyone and welcome back to Data Analysis YouTube channel. For this particular video, we will be going through regression analysis, simple regression analysis and multiple regression analysis with the use of Microsoft Excel. And for the simple regression analysis, we will also do a scatter plot and we will fit the regression line in the scatter plot. So the data that I have in front of me is a data of inflation and unemployment for country X that has been collated from the year 2000 to 2020. And this is the format that I got the data. And let's get started. So for this particular sheet, we are doing the simple regression, and after the simple regression, we will go into the multiple regression analysis. So regression analysis is simply a data analysis method that is used to estimate the relationship between two or more variables. When the variables are two, it is simple regression analysis. So it's just one dependent and one independent variables. But when the relationship is to be estimated between more than two variables, then it is a multiple regression analysis. So in that situation, you will have one dependent variable and more than one independent variables. So the first thing that I would like to do is I would like to transpose my data so that it will be in the format that I can use. If you want to see the step-by-step procedure on transpose, the link is in the description box. There was a particular video that was dedicated specifically to transposing data in Microsoft Excel. And I'm going to just wrap this, or I can just stretch out the column width. If you're new to this channel, please subscribe and hit the like button. And also drop a comment in the comment section. You can also share this link with your friends and your colleagues. If you're a returning subscriber, thank you for stopping by again and welcome. So over to the simple regression analysis. My data has been transposed and I will just get started. So before going into doing the regression, I would like to put a scatter plot. I would like to create a simple scatter plot. So we are going to see what a scatter plot is right now. So to do the scatter plot, I'm just going to highlight the data that I want, okay? And I go to insert, scatter chart, and this is what I have. But I'm going to give a little context to the data that I'm using. So I'm using a data of inflation and unemployment. And since the regression analysis is used to estimate relationship between two or more variables, and we are doing a simple regression analysis, the first things you must do is to identify which of your variables will be dependent and which ones will be the independent variable. So a regression analysis is basically trying to understand how the relationship between the variables are. When one variable changes, how does it affect the change of the other variable? So for that purpose, you need to establish which of your variables is dependent and which one is independent. For the purposes of this particular tutorial, I used inflation and unemployment so that I can also explain the Phillips curve. So the Phillips curve is a theory of inflation and unemployment that explains that the relationship between inflation and unemployment is an inverse one, which means that as unemployment increases, inflation reduces. As unemployment reduces, inflation increases. Okay, so for the Phillips curve, so it's a theory that was propounded a long time ago with a time series data for so many years, and this theory was propounded because of the movement that was observed on the scatter plot that was plotted between inflation and unemployment. Whether that applies till today is another issue of discussion, but for the purposes of this tutorial, we will just stick to learning how to do a regression analysis, whether simple or multiple, with Microsoft Excel. So let us identify what is going to be our independent variable. The independent variables most times are called x's. Okay, so the x variable will be unemployment. The independent variable is the variable that changes, and the dependent variable is the variable that you are trying to understand how it changes when the independent variable changes rather. Okay, so in this case, y is the independent variable. So I'm just going to put, y is the dependent variable. And I'm just going to type this here. And x is the independent variable. So this is a very important step. Whenever you want to do a regression analysis, you need to first identify what variables are dependent and which of the variables is independent. And also, I'm going to write out a basic model to explain the relationship that I've just explained. So this is basically for economics, people who study in economics and people who understands modeling. So basically, I am saying that y, which is the dependent variable, is a function of x, unemployment, okay, and a, which is the intercept, c is a constant. So the constant or the error term, c is the error term, okay? So the error term accounts for the other changes that are not explained by the independent variable that is identified in the model. We know that for economic phenomena all over the world, and for a particular variable, you have more than one factors influencing that variable at a certain time. So this is what the error term accounts for. It explains the differences in the relationship that is not captured by the independent variable. I hope this is clear enough. So A is the intercept, okay? And BX, so X is the independent variable and the B is the coefficient for the independent variable. So this is a simple regression model, and let us get started. So we have already the scatter plot, and with the scatter plot that we have, the scatter plot basically is a visual representation of the relationship between two variables. So you can see from the scatter plot that we have what form of relationship that exists between inflation and unemployment, and you can also see if the relationship is strong or not, right? But with just the scatter plot, you may not really be able to understand. What would make the understanding to be better is when you fit a regression line. So a regression line is a line of best fit, okay? It is the line that will make the sum of squares of the deviations to be equals to 0. And we are going to fit the regression line so that we can just visualize from the scatter plot the nature of the relationship between unemployment and inflation, and then we can even make some inferences just by viewing the scatter plot and by seeing the regression line. So to fit the regression line, we have conditional icons or conditional tabs that have popped up as a result of creating the scatter plot, right? So I'm going to select chart design, and then we see a lot of other options. So you can add chart elements, you can add the axis, right? You can add this one, primary vertical, primary horizontal. You have more axis options. You can have axis titles, okay? So in this case, I'm going to just put here unemployment, because that is the x-axis. And let us see axis titles. And I'm going to put here inflation. Inflation. That's it. And let us see what other edits that we can do. Data labels. So you can also have data labels, right? You can choose to have data labels or not. So in this case, I don't want to have data labels. You can choose to also have error bars. You can add grid lines, right? Or you can take out grid lines as you deem fit. And then there is this legend, right? So you can have legends by the right, okay, by the top. So the legend basically explains what the spots you see on the scatter plot, what it stands for. You can choose to have legends or not. And I want to actually, you can actually update the chart title. So I'm going to say scatter plot for inflation and unemployment. Okay, so you can go ahead to put for country X. I'm going to do that for country X. So just in case you have, and of course you can increase the width, the size of your scatter plot. I put for country X in case you have more than one countries that you're working with, so that it is very easy to understand. And then I go to the next section, which is the quick layout. Okay, I can quickly see a combination of things that of styles that my scatter plot can look like, and I can choose which I want, right? So this one contains a grid line, and it also has some information by the side. So the layout is basically a combination of formats that Excel has put together, and you can see and you actually prefer which one you want. But back to the chart element, I've gone to the trend line, and I am going to put this, okay? So I am going to select a linear trend line. And the reason for this is because one of the assumptions of OLS, okay, is that it is linear, right? So if the relationship is not linear, then it is not OLS, right? You cannot apply OLS to it, so it has to be another kind of econometric analysis method that you apply to it. So this is why I selected a linear trend line. Okay, so there are other options. You have the exponential one, you have the linear forecasts, you have the moving average. So I'm not doing a forecast, okay? So this is why I selected just the linear trend line. So from the trend line that we can see, we can already infer that the relationship between inflation and unemployment for this country X is not inverse, as was proposed by the Phillips Curve theory, okay? And I mean, a lot of things could be responsible for this, and it is in the place of the researcher to explain why he or she is getting this result that is in contrast to the Phillips Curve theory. Okay, so it could also be that the number of observations are not enough to come to that conclusion, because in this case, okay, we are just observing the data from year 2000 to 2020. So it's a time series data. Okay, so like I said, it's the place of the researcher to determine, why do I have these kind of results? Why is it in contrast to the Phillips Curve theory? And then you have to explain. So we have the scatter plot, and we've been able to see the regression line, and then we can decide to add some more information like, let me see, the chart design. If you select more trend line options here, you can decide to add display equation. You can decide to display the equation on the chart. You can also decide to display the R squared value on the chart. Okay, so it depends on what you want. You can come and make these selections here. Okay, so if you want to make a forecast, you can select the period, the forward period and the backward period of the forecast from this particular chart. But for the purposes of this, I am just going to do Control Z because I do not want I don't want the equation to be on the scatter plot. So this is for doing a scatter plot, right? And I am just going to move this data somewhere because I am about to do the regression, the simple regression analysis to get my simple regression results. So to do the simple regression, all you need to do is you come to data, you come to the data tab, and when you select data tab, on the top right of the selection, you should have this icon called data analysis. So if chances that you're not going to have this icon may be high if you have never worked with data analysis icon before. Okay, so data analysis, this particular icon is one of the add-ins in Microsoft Excel that is not readily integrated into Excel. And when you need it, then you have to go and look for it. So in case, just in case, you do not have this data analysis icon in your Microsoft Excel, not to worry. I did a very comprehensive video how you can find the data analysis icon and integrate it to your Microsoft Excel. But just to do a quick rundown as well, you can just click on File, come to Options, and then you select Add-ins. It's taking some time, and then the data analysis, the analysis tool pack will be, okay, here it is active right now, but before now it was inactive. It was part of the inactive applications. And then you come down, you select Excel add-ins, you click on Go, and you click OK. And then you have to make a selection of analysis tool pack. Okay, like I mentioned earlier, the step-by-step video, the link to that video is in the description box. So do well to click on that link and see how you can integrate the data analysis tool pack onto your Microsoft Excel so that you can also do the regression analysis just like I'm about to do right now. So I highlighted the entire set of data that I want to use for the regression. And mind you, I'm not highlighting the year because the purpose of this showing up just shows me that it's a time series data, right? It's a time series data. So I don't need the year for anything. These are the variables that I'm concerned about: inflation and unemployment for country X. And I select data analysis, and then we have a lot of options. I am going to select regression, and I select OK, and I have this beautiful dialog box which has just popped out. So it says impute Y range, right? So in our own case, Y is, I always like to double check, by the way. So the Y variable in this case, so every time that you write it out, it's going to be super helpful. Y is inflation and X is unemployment. So I select data analysis. Regression is highlighted already. I click on OK. And the Y range is inflation. It's already been highlighted. Okay, so I am going to highlight this down. And just like you can notice, I also selected the heading. Okay, and the next one is to impute the X range. And I am going to make this selection. And this is it. So labels, I have my labels selected. So this is why this is highlighted. The output options. So basically, Excel is asking you, the outputs that you will have, where do you want it to be? Output range shows you have to select where you want your summary outputs to be. When you select output range, it means your summary output will be on this same worksheet that you're working on right now. If you select new worksheet ply, this means Excel will open another worksheet for you, maybe this time sheet 4, automatically. If you select a new workbook, this means that your regression results will pop up in a new workbook that Excel is going to open for you as well. For me, I would like my result to be represented on this particular worksheet that I have on right now. So I am going to select output range, and I have selected F5, so you can make any selection actually. And you click OK. This is the summary output for my regression, my simple regression analysis. So this is my summary output. I can just move this here. Good. So this is the summary output that I have. The summary output for the regression, the simple regression analysis in Microsoft Excel is showed in 3 different parts. So we have the first part, the regression statistics, and we have Anova, and we also have the main regression results that explains the significance of the relationship for the individual variables. Sorry about that. So for the summary output, so for the regression analysis, the regression statistics rather, it explains the fitness of the entire model, okay? So beginning from multiple R, so what multiple R explains is the correlation coefficient that measures the strength of the linear relationship between the variables. Okay, and it is usually from -1 to +1. Okay, so if your multiple R has a negative sign, it means that the linear relationship between the variables is negative. When it is a positive sign like we have here right now, it means that the linear relationship between the variables is positive. And of course, we can see from the scatter plot, this relationship that we have is upward. Okay, it's an upward relationship showing that it's a positive relationship. So this also explains the multiple R, and the larger the figure, okay, the stronger the relationship. So if the closer the figure is to 1 or -1 shows the stronger the relationship. In this case, it is 0.22, which means that the relationship is not so strong. And as we can see, the slope is not really steep. So this is actually good. And just like I said, the scatter plot already gives you an insight to what results you should be expecting from your summary output. Now, the next one is the R-squared. The R-squared is the coefficient of determination. It shows the goodness of fit. Okay, it tells you how many points fall on the regression line. And like we can see, we do not have so many points that fall on the regression line. A lot of the points are scattered outside the regression line. And this is, I guess this is why our R-squared is 0.049. Okay, because for the R-squared, it is actually between 0 and 1. Okay, the closer it is to 1, it shows you that the model, the entire model is fit. And the next is the adjusted R-squared, which is not very relevant when you're doing a simple regression analysis, because the adjusted R-squared is the R-squared that is adjusted for the number of independent variables. And next, we have the standard error that shows the standard deviation of the sampling distributions. And then, of course, the observations tells you the sample size. In this case, it is 21. Okay, if we want to do this quickly by using the count formula, so you have count, and I'm going to select everything, and this is what we have, 21. If you want to see how we're doing with the count formula and other formulas, there is a link in the description box to explain that as well. Okay, so over to the next section, which is Anova. And like I mentioned earlier, so the purpose of this tutorial is not to explain econometrics or is not to explain OLS. The purpose of this tutorial is to show how you can use Microsoft Excel to do a simple regression analysis and a multiple regression analysis. Okay, so I may not really go deep into the econometrics part of the results. And then we have, for the Anova part, we have significance F, right? This is the probability. It shows you the probability of the goodness of the fit of the model, how statistically significant the entire model is. And the rule of thumb is when your probability is below 0.05, it means that the model is statistically significant. When it is above 0.05, it shows that it is not. So in this case, it is way above 0.05, so it says that the entire model is not statistically significant. And then we have the F statistic. The rule of thumb is that when it is lower than 2, it is not statistically significant, and when it is higher than 2, it is statistically significant. And then we have the sum of squares, and we have the mean sum of squares as well, which is the sum of squares divided, okay, let me get that right. So the mean sum of squares is the sum of squares divided by the degrees of freedom, which we have here, okay? So the total, of course, is the sum of the regression and the residual. And onto the third section of the regression solution, or the summary output, we have the coefficients. So we have the intercept, okay, which is 10.16. That is the intercept, which in this case is A, okay? So we have the standard error and we have the t-statistic. So if you want to understand the statistical significance of the intercept, you look at the t-stat and the p-value, okay? The p-value, the rule of thumb, like I said, is 0.05. So in this case, the intercept is statistically significant, and also the t-statistic also confirms that result. But for unemployment, which is the only independent variable that we have, okay, the coefficient is not statistically significant because the p-value is above 0.05. So what this means is that the relationship between inflation and unemployment is not statistically significant, okay? So it is in the place of the researcher to explain why this is the case for country X. So this is what we have for simple regression analysis. So we will go into the multiple regression analysis. Like I mentioned earlier, for economic phenomena, most of the time, for a particular variable, just going to undo that. I want to transpose. Awesome. So for economic variables, most of the time, it is not affected by just one factor alone. In real life, okay, inflation is affected by a host of other factors. For example, you have inflation being affected by interest rate. Inflation is also affected by exchange rate for a very import-dependent economy. And just to also explain some context to the Phillips Curve theory, because someone might say, what is the logic around the Phillips Curve theory? So basically, the Phillips Curve theory is trying to explain that when you have, okay, when you have low unemployment, okay, this means that you have a lot of people who are employed, right? Low unemployment means that the employment rate is very high. There's a lot of employment. It is saying that at that point, there is also high inflation. And this can be explained from two different areas. So you have demand pull inflation that comes from too much money chasing too few goods. So when you have a lot of people employed in a society, you have a lot of people earning income, and then you have a lot of buying, okay? A lot of economic activities go on in that society. As a result of that, you have a lot of money, okay, chasing too few goods. And this is assuming that output cannot change as fast as okay, the demand is changing, which is the case most of the time, okay, because in trying to change output, you have to increase the factors of production, you need to expand the industry, which doesn't happen overnight. Most times there's a time lag for this. And then there's another aspect, which is cost push inflation. This is the inflation that happens when the factors of production become more expensive for the people who manufacture. So one of the factors of production is labor, okay? And typically in a society where employment is high, people can get jobs as much as they want, okay? The value for labor becomes more expensive, okay, because it is becoming super competitive. There are a lot of jobs all over the place and people can easily get jobs. So the labor rate becomes quite competitive, and the knockoff effect of this on the business is that laborers may begin to request for higher wages. Now, the impact of this is, as they request for higher wages, they eat into the profit of the entrepreneurs, and the entrepreneurs, on the other hand, respond by increasing the final cost of goods and services. So, which is basically inflation at the end of the day. So this is the layman logic, okay, around the Phillips Curve theory. But country X gives us something else. Country X is saying, well, this is not the case. In country X, according to the scatter plot that we have here, it is saying that as unemployment increases, inflation increases as well, and which is actually an economically scary situation, because this explains stagflation, where inflation and unemployment is rising at the same time. So I'm going to stop there for the economic explanations because, like I mentioned, the purpose of this tutorial is to explain how you can use Microsoft Excel to do multiple regression analysis and simple regression analysis. So we are not going to talk about economics a lot. And another thing to point out, okay, is that now we have this data. So first, just like we did for the simple regression, we are going to identify the dependent and the independent variables. So Y, which is the dependent variable, okay, the dependent variable is the variable you're trying to observe. The variable you're trying to observe, okay, how does it change when the others change? Basically, that's what it is. So in this case, our dependent variable is inflation, and then we have x1, okay, and we have x2. So we have more than one independent variables in this particular scenario. So we are going to have x2 is now interest rate. So we are assuming that inflation is also impacted. There should be also a relationship between inflation and interest rate, right? You could have as much variables as you want, okay, to explain the economic phenomena that you have at hand. And then let us write out the model. So this is what the model would look like. We will have B1 x1 plus B2 x2 plus A plus C. Okay, so B1 x1, B1 is the coefficient for unemployment, B2 is the coefficient for interest rate, A is the intercept, C is the error term. So this is basically the model that we are trying to look out for. So we go straight to do the data analysis, to do the multiple regression analysis rather. So we click on data analysis, and here we have regression. We select regression and we click OK. So we need to choose the input Y range. The Y is inflation, and I am going to make the selection. So I click here Excel already highlighted all that for me. And for the X range, so you're going to select all the independent variables at the same time, right? So I selected all the independent variables and I leave my label checkbox ticked because I also selected the labels. And my output range will be F5, which will be somewhere around here. But of course, I can change that. Woo. Okay, so what I see here is that I'm actually changing the wrong thing. And this, I am going to change this. I want it to be here. And okay. So what is Excel saying to me? Oh, wow, I have a lot more than I'm supposed to have. And I select okay. Awesome. So this is what we have, okay, for the multiple regression analysis. This is what we have, okay? And like we mentioned, for the multiple regression analysis, your adjusted R squared is what you prefer to the R squared, right? Because the adjusted R squared has been adjusted for the total number of independent variables that you have. And like the same explanations I gave for the simple regression analysis summary outputs, it also suffices for the multiple regression analysis output. So it's the same explanation. We have for the regression statistics, we have for the Anova, and then we have the regression result itself, okay? So we see the coefficient of the intercept, we see the coefficient of unemployment, we see the coefficient of the real interest rate. So if we want to rewrite this model that we have, I'm just going to do Control C and put it here. So we are basically going to write it like this is equals to, okay, so B1, X1, B1 in this case is 0.39, X1 plus, and in this case it will be minus, okay, because it's a negative sign. 0.037 X2 plus 10.388. Okay, so I'm just going to also put one more decimal here. And this is what we have. Whenever you finish your calculation, of course, the error terms will not show up, right? There's no value for the error term. It was for the purposes of illustration and to also back up the ordinary least squares assumptions. When you're writing out your model, you need to show the error term. But during the analysis, okay, the error terms are absorbed. To really understand that, you need to consult, of course, an econometric text to really understand what happens to the error term at the point of the analysis. So this is what the model will basically look like, okay? And to check the statistical significance of these coefficients, you look at the t-stats and you look at the p-value. From the p-value, what I can see is that only the intercept is statistically significant, okay? Only the coefficient of the intercept is statistically significant. The coefficients for unemployment and real interest rates are not statistically significant. So you can conclude that the relationship between inflation and unemployment and the relationship between inflation and real interest rates is not statistically significant for country X. Ceteris paribus, all other factors remaining constant, because as it relates to this model and with the information that you have, this is the result that you have. Okay, so thank you so much for staying up to this point, and please give me a thumbs up and subscribe to this channel if you're yet to. Share with your friends and your colleague, and drop a comment in the comment section as well. Thank you for stopping by, and see you another time.